Okay, I would like to thank the organizers. Thanks for being here. The take-home message of this talk is very brief. Good physics is simple. And fortunately, there are still some people who agree with me, but the question is, what does simplicity mean? And I will try to give you a definition later, but we also might try to learn from examples. According to particle physicists, the most simple explanation of reality is like this. Up quarks, down quarks, strange quarks, jump quarks, bottom quarks, top quarks, 3 colors each, electrons, muons, tauons, electron neutrinos, mu neutrinos, tau neutrinos, W bosons, Z bosons, Higgs bosons, gluons, and so on, and so on. I think there were reasonable people in particle physics. Enrico Fermi said, if I could remember all these names, I would have become a botanist. But the problem is all these reasonable people died before the standard model was developed. So in a way, I prefer the dead physicists over the living ones. If the Lord Almighty had asked me before embarking creation, I should have recommended something simpler. This was King Alfonso of Castile, and when he said this, he had visited the library of Toledo, and he first saw the epicycles of the geocentric model. So I'm just curious, if you look at this standard model, how many of you believe that, raise your hands then, yeah? How many of you believe that this is the fundamental theory, the ultimate description of reality we may hope for? Nobody. One.
Fundamental and ultimate.
Two. Okay, one or two. Just a few people. Yeah, that's good. Otherwise, I mean, I would have suggested there is also an interesting section going on over there. But who instead believes that, raise again your hands, who instead believes that the standard model is a successful, effective theory that one day may be replaced by something more fundamental? Who is of this opinion? Okay, that's what usually everybody says. I'm sorry to say that, but I think that you're still fooling yourselves, because epicycles are not an effective theory of anything. And for that reason, they went to the junk room of history, and that's where they belong to. So I believe that a system of more than 50 free parameters at the very end cannot make sense. And I also think that some people are in agreement with me. Einstein had some very interesting quotes in his later years. There is a very interesting book by Rosenthal Schneider. Numbers arbitrarily chosen by God do not exist, and their alleged existence relies on our incomplete understanding. So my proposal is, if good physics is simple and the simpler theories are better, there is a simple measure for simplicity, the number of free parameters, or we might call it also the number of fundamental constants. And if we try to go back, and if you look at the development of science, you know about this brilliant book, The Structure of Scientific Revolutions, and that's how science works. We have an anomaly, we have a free parameter, and we have a complication. And then we have this period of normal science where the complication increases, and then it happens once in a while, as in the stock market, the model crashes and we end up with a new paradigm. And if a paradigm changing ideas occurs, that we have immediately less free parameters and a simplification. And by the way, simply that simplicity is a measure of a good theory. It's not my personal fancy. I think that the history of science perfectly tells us that the real revolutions in physics, they all have been related to simplifying physics, to reducing the number of fundamental constants. Why is electromagnetism scientific revolutions? Because we had the electrical and the magnetical field constants, and they were related to the speed of light, reducing the number of independent constants from 3 to 2. And I will also point out later that quantum mechanics reduced the number of fundamental constants. It was a tremendous simplification in this sense. And of course, the best example in history, it's Newton's law of gravity, which condensed dozens of unexplained parameters of the epicycle theory into just one gravitational constant. So, if the number of fundamental constants is the measure of quality of a theory, what are the most fundamental constants, and could we think about to get rid of these fundamental constants too? And I will talk about today about C and H. I think that the gravitational constant G is not as fundamental, but I can just mention today, briefly today, a very beautiful idea of Einstein, because Einstein was in Prague actually when he wrote his 1911 paper about the influence of gravity on the speed of light. And I think this is a very, very interesting form of general relativity based on a variable speed of light. You see that that was Einstein's very first idea when he thought about light deflection. And anyway, this is a sideway I just wanted to show. And I think Einstein would have been thrilled if he had known about the size of the universe back in 1911. And there are also interesting relations to Mach's principle and to other researchers that contributed to this theory. That's why I'm not talking about G very much today. But let's get back to fundamental constants. Einstein said, I cannot imagine a theory containing an arbitrary number which could have been chosen by the creator in just another way. That in first place, it may refer to what we call our parameters in particle physics, or it may refer to numbers like the fine structure constant, but in a broader sense, it also refers to constants of nature such as H and C, because they are not explained from first principles. Think about possible extraterrestrial superintelligence. Why should they necessarily describe reality with constants of nature C and H? Why do they exist at all? Why couldn't they use just pure mathematics? Okay, this is the question. And the hypothesis is that C and H might be anomalies of Newtonian physics. This is a Kuhnian approach. If you say, okay, if you have a simple, beautiful theory, and then you have anomalies, unexplained phenomena, you bring up a new free parameter. In this strict sense, it may seem exaggerated to you, but in this strict sense, C and H are free parameters that cast doubt on the very basis of Newtonian physics, on the concepts of space and time. Because there is no reason whatsoever from Newtonian physics that matter should not be accelerated beyond the speed of light. There is no reason from first principles. Why should that be the case? And back at the time of Newton, it was just an isolated curiosity discovered by the astronomer Römer, okay, that light, but what was light? Seemingly it didn't apply to matter. But then the problem became more severe when the speed of light appeared to be a limiting velocity also for matter, and it had obviously a significant impact on the dynamics of Newton. So the very existence of C is a failure of Newtonian physics at the large scale. And of course, all this was brilliantly resolved by Einstein in his special theory of relativity. This is a fantastic theory because it's coherent and it explains time dilation and length contraction and mass increase, and think about electrodynamics. That's wonderful how the Lorentz transformations of electrodynamics of the Maxwell's equations. All this is a brilliant theory, and it uses just one parameter. But that does not mean that space and time are really four-dimensional. Okay? This is a separate idea introduced by Hermann Minkowski, and I think this is one of the most consequential misconceptions, one of the most catastrophic errors of modern physics, to believe that space and time are the same quantities and c, the speed of light, is just a scale factor. No, it does tell us something, and if you say that space and time are the same, you're literally departing from your senses. Okay? So I think that Minkowski was a brilliant mathematician, but he didn't understand much of physics. He was the real bad guy. That's what Einstein said about first when he came to know. No. That's what Einstein said about. So Minkowski was maybe an ingenious mathematician, but his thinking was not physical. He was the real bad guy. Much worse than Ed Witten, by the way. No. Oops, I'm going. Okay, so we're going to the next anomaly, H, quantum mechanics. There is no reason for discontinuous phenomena in classical physics. And by the way, I think it's bizarre that physicists use all the concepts of mathematics. They use continuity, they use differentiability, they use open sets, and all this beautiful mathematics. But once you get to the basics, to the small scales, you have this excuse, oh, you have to use quantum corrections. What does that mean? They just gloss over the problem and are allowed by mathematicians. I wonder why. And of course, quantum mechanics is also a brilliant simplification, because first of all, Planck did simplify physics when he unified the Rayleigh-Jeans and Wien's law of radiation. That was a unification that eliminated one constant of nature. And then another one occurred. Einstein discovered the photoelectric effect that would have created another constant if it wasn't discovered that there was a relation. And then Bohr discovered the significance of H for atomic physics and explained away Rydberg's constant, which was discovered by Boltzmann in 1885, long before. So again, and we have the Josephson effect, and we have the quantum Hall effect. So again, we have a tremendous simplification of physics by just one constant of nature. Yet it might be one constant too many. And H might be an indication of the failure of Newtonian physics at the small scale. And it is a problem that C is not infinite and H is not zero. C and H indicate there is something wrong with the axioms of Newtonian physics, space and time. And these are axioms. Newton just postulated space and time because it seemed so obvious to him. But what if he was wrong? What if space and time are just the most obvious frames of human perception and there is something deeper? I think we have to do pure mathematics, and those who know my views about string theory, they might be amused that I agree with Galileo. The Book of Nature is written in mathematical language, but I think there should be a reason for the constants of nature, C and H, from first principles. And we're not approaching fantasy land or string theory or 26 dimensions or 10 dimensions. I don't even believe in 4 dimensions. Let's consider the possibility that reality is truly 3-dimensional. And let's enforce simplicity. Let's consider the most simple manifold, which is S3, the unit sphere in 3 dimensions. Has a couple of names. There is a homeomorphic to to S3 is SO2. The group, so S3 in a way is able to operate on itself. It's equivalent to the unit quaternions, and it's the double cover of SO3. I will talk about this. This is another representation. And S3 is the most simple thing because it's the only simple connected three-dimensional manifold. That was proven by Grigori Perelman recently. So we have a very, very interesting mathematical object, and we try to get out some physics from this pure mathematics. So once you're doing mathematics in a manifold, you necessarily have a tangent space. Now look at this tangent space. I depicted that's the unit for in 2 dimensions, but S3 is just the same thing in 3 dimensions. You have a tangent space there, which is flat, and imagine you're walking around on the surface on the sphere, and in every instant you have a different tangent space. So in every point of the surface, you have a different 3-dimensional world appearing to you. So if you think about walking around on S3, this sequence of 3-dimensional tangent spaces might well create the illusion of an extra dimension. But that's not really a 4th dimension. It's just a tangent space in 3 dimensions. And then there is another thing. The manifold, despite being a curved manifold, locally it looks like the tangent space. But it's not the same, okay? The S3 or SO2 is a Lie group, a differentiable group. And the tangent space is the Lie algebra. The difference is subtle, but it's significant. The elements of the manifolds are very similar to rotations, and you know that rotations can be represented by a vector, axis, and angle, but it's different. So you might think about the tangent space as an essential object, but how could something like a constant of nature arise from this pure mathematics? Because a constant of nature is necessary if you want to equate 2 objects which are qualitatively different, okay? If you do mathematics, you have just one number here, one number there, it's an equation. If you do physics, you have physical units. So here we have 2 different objects, the manifold and the tangent space, and we might be tempted to equate these objects in these of different quantities, and when doing so, we are doing something forbidden, and we are equating qualitatively different entities. And that might be the reason for the emergence of C. C must be somehow related to this tangent space. And think about it. It's also all the information we can get from C, from the tangent space. C might be the very fact that we try to perceive our world by linearizing. So the tangent space could be related to the light cone classically. But this is one constant of nature. So there are other intriguing properties of S3, and the most prominent one maybe is that it does not commute. Okay, if you take an object and you rotate it clockwise, clockwise, anti-clockwise, anti-clockwise, it's not in the same direction. It's not in the same orientation as before. Clockwise, clockwise, anti-clockwise, anti-clockwise does not commute. Okay? And this is a problem. Remember, you were doing just mathematics, but in first approximation, we may be tempted to represent objects of S3 as vectors, because vectors represent rotations, and vector addition is linear, but the concatenation of objects in S3 is not linear, it's nonlinear. So by falsely assuming that you're dealing with vectors, and instead you're dealing with elements of SO2, you may equate objects that are qualitatively different, and you may do a little error, and the result of this little error may be a very tiny constant h, which arises from the very property of S3 being non-commutative. And there is ample phenomenology that somehow h is related to non-commutative processes. Think about the angular momentum operators in quantum mechanics and all this. And there is a third very interesting property of S3 I want to point out, of the group of rotations. SO2 is a double cover of S3, okay? So take a book, you best take a book about algebraic topology, but it works with any book. Take an object and rotate it, make a full rotation in three-dimensional space, which is a full rotation of 2 pi. I'm trying to do this. I keep the object, but I rotate it. So here I am. Rotated by 2 pi, and it's in the same orientation. My body is in the same orientation too. But the path from here to here is not a trivial path. And if I try to contract it, I would wreck my arm. So what happens if I continue to twist in the same directions? Don't worry. Nothing happens. Another rotation's by 2 pi, and I'm in the original state again. Now, this is a purely mathematical property of the rotations in three-dimensional space, and its double cover, which is SO2, which is the same thing as S3. So again, here we have an intriguing behavior that reminds us from physics. Of course, the double cover reminds us from the 2 spin states. And we have a relation that of a manifold that could create the illusion of something like a three-dimensional space. I think this is an interesting perspective, so I'm going to the conclusions, really long conclusions. The first conclusion is good physical theories are simple. The standard models of cosmology and particle physics are complicated. Real progress in physics has always eliminated arbitrary numbers. Consequently, a complete theory of reality must do without any constant of nature. That's the goal. And I think that C and H are anomalies that cast doubt on the validity of the axioms of Newtonian physics. Space and time are very different things. There's no reason why reality should have such a peculiar three-dimensional structure. There's no reason why nature should present itself in this fashion. Rather than about the origin of space and time, one has to wonder about the phenomenology of light and matter. By the way, I forgot to say, if we think about this three-dimensional picture of reality, then all the laws of nature would be encoded in a connection on this manifold, which is a well-known concept in differential geometry. So, well, if I look at you, the danger is that you say, well, it's a nice talk, but so what? So I'd have to try to upset you another little bit. Many of the problems we're wrecking our brains might be ill-posed. So it might be that there is no wave-particle duality. It might be there is no measurement problem, no collapse of the wave function, no unification of general relativity in quantum mechanics, no non-locality, no violation of causality. There might be just one big misunderstanding that space and time are inappropriate concepts for describing reality on a fundamental level. A sequence of tangent spaces of a three-manifold on the three-manifold may create the illusion of one more dimension. Reality might just be S3, SO2 and the Lie algebra. C might be a consequence of the tangent space, as H might be a consequence of the non-commutativity of S3. C is related to light and H is related to matter. Now, where can you find this? The thing I mentioned earlier, this cosmology of Einstein's variable speed of light, is in this paper. And there is another more recent paper about the Machian version of Einstein's variable speed of light theory. The paper about C and H should be on arXiv, but guys like me have the privilege that they need special attention by the moderators. So that's why I tried to get some readers from Amazon too. This is a book, it appeared at Palgrave and Macmillan 2 years ago. And this is my book about the development of particle physics. I think this is a much better book about particle physics. I would really recommend this particle physicist Andrew Pickering to know what the experimentalists do. And well, here we are. The question that remains is, space and time need to be replaced. So, I have finished here. You're invited to raise objections. Thanks for your patience.